Hello friends, today this is an exclusive step-by-step guide to factory I/O. So we are going to see how to deal with the factory I/O with PLC automation step by step, and it's gonna be so easy for the understanding. Please don't forget to subscribe, like and comment, and please share, and also watch the video up to the end for a better explanation. There we go. So this is our factory I/O software. Actually, this software helps us to provides us with the real components and the real materials of an industrial setup, so that you can use it to give the real training of our automation skills. A brief preview through this factory. It has some scenes here. This is conveyor. It has various scenes. This is a filling tank, and this is the assembler. It deals with both analog and digital programmings. We have here automated warehouse. We have buffer station, coverage station, elevator control. It has very many scenes. And when we go back here, these are the parts that some of the parts that it comprises of. I can give a clear view here. When we say new, for example, it has all these components that you see here. These are boxes, these are stackable buckets, these are the products. They act as products. We have this one is a chain transfer. We have 2-meter roller conveyor, 6-meter roller conveyor. We have very many components here. We have this is a curved roller conveyor. We have 2-meter belt conveyor. We have this one is a turntable, if you know what a turntable is. We have very many components here. We have this is a pusher, this is a left positioner, this is straight spar conveyor. We have this one is a pop-up wheel sorter. We have very many components in this software here. Then we have this is a capacitive sensor, this is a diffuse sensor, we have inductive sensor, we have retroreflective sensor, we have this is a reflector, this is a RFID sensor, this is a vision sensor. We have here emergency push button. We have a variety of materials here. Have light indicators, they are here. We have this is digital display. We have analog potentiometers. We have these are our start stop push buttons. We have this is electric switchboard. If you want to do a switchboard, we have here water tank, we have buzzers. There are very many components here in factory I/O. Just find the link in the description below and get your own software and try to view everything in it. Like for example, if you have here a 6-meter roller conveyor, just drag and drop in the space like that, then you'll have your conveyor ready to be used. You see? So that is a 6-meter roller conveyor, for example. And now with this factory I/O, we have here what we call drivers. This is how we control. On this side we have what we call sensors, and this side we have what we call actuators. If you're well versed with the PLC language, for sensors, it is not only necessarily sensors, it can be even push buttons. It can be any input device is going to be aligned on this side, and any output device can be a conveyor, can be an alarm, it can be a light, it can be a valve, is always going to be aligned on this side. And what is going to be in the middle here, it will be our PLC, which has not come yet. We shall see. It will be our PLC to help us connect the input devices to the output devices. The way you see this roller conveyor is the one I've so far put in our workspace. That's why it is here. This one, the rest factory I/O, what we shall ignore them. We shall only be considering whatever we put there is what we consider. So to make this video so quick, I'll delete this one. Then we are going to use already a setup scene for the startup. So we are going to go home. We are going to come to scenes. We are going to have this conveyor here. Are you seeing? So we have already set up this one. We have a conveyor. We have here a box. Then this side we have a sensor with a reflector. So when we come here in the drivers, we have here sensor. As you see, we have one sensor there, then we have one conveyor. So that is what we are going to deal with. So we are going to come up with a PLC program to help us control this conveyor here. We are going to move this box up to this side, and when it reaches this side, the conveyor will stop. Please, as we continue, don't forget, before we continue, I bring for you a very nice and excellent institute called the Rishamo Vocational Institute. It is located in Jinja. Please, for more information, get the contacts below, and the location is there indicated on the screen. Find all the skills, come do all your courses. More so, electrical automation. This is the only center that can provide very nice skills in electrical and industrial automation and even smart home designs. Come at Rishamo Vocational Technical Institute in Jinja and exercise your skills. So now we continue. We are going to go to our PLC software. Now here, when you look at the drivers, we have this factory I/O deals with various brands of PLCs. You have Allen Bradley Logix 5000, up to we have Autogen server, we have Control I/O, we have OPC servers, Modbus TCP IP clients. It has Siemens logo, Siemens S7 PLC. It can be controlled by all those types of PLC. But me, this time I'm going to use OPC client because I'm using a Mitsubishi PLC. So there we go. I'm going to open up my Mitsubishi PLC programming software, and we call it GXWorks, which is right here. We are going to open GXWorks 2, and also don't forget to check the description. We have the link is there. Access your own software and try out your skills with PLC automation. So there we go. I'm using GXWorks 2 version 1. There are various versions. We even have GXWorks 3. Whatever you get, it is going to work for you. It is going to work for you. Find the download links in the description so that you can have a good way to go. So this is Melsoft Series GXWorks 2. It has already opened. We are going to be so quick a bit. So you are going to come here to project. You are going to open a new project. I'm going to leave QCPU Q mode. Everything I'm going to leave the way it is. This is ladder. We are going to do ladder programming. I'm just going to say okay. Now there we go. So this is our main workspace of the PLC programming software. We have what we call registering variables, but for now we shall do it locally. So when I come here to our software, we first have to analyze how many inputs and how many outputs we have. So what I'm going to add here, I'm going to add a start and stop push button. I'm first going to add this control box here. It is facing the other side. I'm going to tilt it. Then we are going to have a start and stop push button. As you see, I have here start push button. Then we have here a stop push button. So they are facing the other side. Let me tilt them like that. This one also. Like that. So I'm going to position them properly. There we go. So after positioning my start and stop push buttons. As you see, this is start push button 0, this is stop push button 0. When you come here in the drivers, so the input devices we have, there are 3. We have start, we have stop, we have sensor, then we have conveyor. Conveyor is one direction, that is only forward. So in our PLC programming, we are going to mind only those input and output devices. So when we come here, we are going to have our normally closed contact, then this shall be X0, then we shall have our normally open. So since this sensor is also going to help us, this sensor is going also to help us in stopping the conveyor, we are going to have two stopping inputs. So we shall have another normally open, shall call it X1, I mean normally closed. Then we shall have a start X2, and finally we shall have our memory. So I'm going to have here memory, that's M0. In real wiring there you can use a relay. So I'm going to have here the self latching of the memory, that's M0. There we go. So now after that, we are now going to have here an open contact of the M0 to power for us our output, and that be the contactor of the conveyor, shall be, that will be the conveyor, and we shall have Y. So in this PLC, X, we use X to address the inputs and we use Y to address the outputs, then M to address the memories, plus other components, as we shall be seeing in various examples. So this is a complete. This is complete. We have already finished. This shall be our stop push button, X0, then X1 is going to be the sensor, then X2 is going to be the start push button, then M0 is the memory, and Y0 is our output for the conveyor. So we are going to come here, compile, then say build, then we are going to have online, we are going debug, start and stop simulation. So there right away we are going to start to put our PLC in a simulation. Yeah, so this is our GX simulator 2. It is already in a run mode. So I'm going to minimize this. So we are going to minimize it. It is already running in the background, remember. So I'm going to open a software called MX OPC Configurator. This one is going to help me connect the PLC to the factory environment that is created in factory IO. So also the software, get the link in the description below. I'm going to use MX Configurator. Let me first delete this one. For you, when you start yours new, you'll have nothing here. So here they are saying right click to add a device. I'm going to right click and say new MX device. Mine is bringing device 5 because I've added the various devices multiple times. For you, for the startup, is going to bring device 01, and you can rename it if you want. So we are going to come here in configuration, then the connection, we are going to say GX simulator 2, because remember in our GX works we are using simulator 2, which is right away here. GX simulator 2, that's why here we also choose GX simulator 2. Then we say next. Comment you can ignore, you say finish, then here you say okay, then also here you say save. So that is already devices added. After doing that, you are going to say right click to add data tag. This time is now not new but data tag. So you are going to right click, we add new data tag. So we are going to name this. This one is going to be our sensor. Remember, the sensor is X0. we say save and new. So it has already saved the sensor is here, so we are going to tagger 2. Tagger 2 is the stop push button, and it is X1 already. Then save new. Then another tag is the start push button, it is already at X2, then that is save new. Then another tag we have conveyor, and this is now not X3 but conveyor is at Y0, then you say save. So you have our sensor, stop push button, start push button, and the conveyor. So we are going to put in monitor mode, try to check. Yeah, you see here it is all quality good, quality good, quality good. Thanks. There we go. So I'm going to minimize this. It is also already running in the background. Then I will come now. Allow me make some change, and please, if we are doing PLC programming, we should always put this in configuration, the type of contacts you are going to connect physically and the programming here. What do I mean? Let me first put this in the right mode. So here our stop push button, it is normally closed. This one here, this one is normally closed. So what does it mean? If it is normally closed, and also here we have put normally closed, it's going to open and it's not going to allow. So if it is normally closed on our distribution panel, here we have to make it normally open. Here we have to make it normally open, so that once we connect, it is going to close automatically. I don't know whether you have got it, but let's move by that. So I'm going to build this one again, and I'm going to write it to PLC. Remember, it is already in simulation, the PLC is already running. So I'm going to write it in PLC. So select all, execute, yes, yes to all, okay, then yes, okay, close. So it is already there. Now when I put it back in monitor mode, you'll find here it is only this one which is closed, this one is open. But when you are going to connect our push button, the real push button, it is going to close. So how do we now connect? Remember, we are done with the GXWorks PLC programming, our data logic. We have connected our MX configurator, it is already in simulation running. Then now we shall come to this factory I/O of ours. Then we come to drivers, and here we are going to choose the PLC we are using. Now me, I am using Mitsubishi PLC, but here you will not find it. Mitsubishi, we use OPC client. So I'm going to select OPC client, and I'm going to give it time to search. Oops, here is saying OPC client host unavailable. Don't mind, that is okay. So we are going to come here in configuration. Then we are going to browse for servers. So after we are going to check here OPC server, we have here, it has to bring Mitsubishi. Mine has brought Omron because I also had some Omron server sometime, but here it has to bring Mitsubishi if you are dealing with GXWorks, because that is a Mitsubishi software. So this is Mitsubishi OPC. So here we are going to browse items or nodes. Don't forget to click browse. Then from there we are going to go back. Now there you will see this tick, it shows that it is rightly connected. Now our PLC that I was telling you is here. So on our PLC we have, this is the input terminals, these are the output terminals. So we have the terminal connected that is going to connect the conveyor, the sensor, the start and the stop. So when we shall carry our sensor and put it directly to the terminal of the sensor, we carry the start button is going to start, then we carry the stop button it comes to stop. Then we carry the conveyor, it comes here at the conveyor. Are we there? So that one will be already done. Yeah, we have here some start button light, you have stop button light, but you have not programmed for the lights. You can include that in your ladder logic, no problem. So after here, we are going to go back, then we are going to say run. Now when I put in run mode and I come and check my PLC program, you will see that this one is already closed. What I told you, it is already what? It is already closed. Now for it being closed, actually X0 has opened. Remember, it is in a simulation. So what is that meaning? X0 has opened. Oh, remember this one is a reflective sensor. This sensor here is reflective, so it is already receiving the signal. Our object is the one supposed to block that signal. So now that means the sensor is in a normally closed state. So that means since it is normally closed, here also you have to put a normally open contact. So I'm going to come here in write mode. I'm going to put a normally open contact, that's X0. And I'm going to compile build, then online write to PLC. So that's why we need to be doing these practices, and this software is very nice, Factory IO, because it can help you come up with all these troubleshootings before you submit your program for the real-time functioning. It is very nice when it comes to your own self practices, and I encourage you people, please get it. The link is in the description. So after writing to the PLC, I put it back in run mode. You'll find that yeah, now they are all, X0 is now closed, X1 is also closed, and it can allow X2 to complete the circuit in case we press a start push button. So there we go. Now when we come back to our real factory here, and this is the stop, this is the play. Play is now simulation mode. So we are going to click start. You'll see it is going to start the conveyor there, and after reaching the sensor, it's going to stop. Have you seen? It is going to stop. So let me refresh. So I'm going to give so that we can be seeing what is happening in both instances. So start, when I press stop, it is going to stop there, and then again start. So here when it reaches the sensor, is going to stop. Yeah, so now how can we solve this problem? We can extend our sensor at a bit somewhere this way. Let's do it. So we are going to press here stop, then we come here in editing. So we are going to move our sensor a bit. This can give some space for the object now. So when we do again our simulation, we are going now put in play mode, then we shall have start. There, stop. At least there it can stop before our box falls off. The way I can show you here in simulation. Please don't forget the Rishama Vocation Technical Institute is located in Jinja. Find the contacts and the location on the screen, and please, all the links of the softwares, find them in the description. Don't forget to like, share and comment. So when I press start, you see what happens. It is start. So it's going to reach the sensor, and this one is going to open. Very good. It opens and the conveyor will stop before our box falls off. Please, if you have not understood, you can reverse the video, you can slow up, you can pause the way you want, but don't forget you have used 3 softwares. Our main software is here, is called Factory IO. The PLC software is here, is called GXWorks2. Then the link that helps us to link them is here, called MX Configurator. Find all the links in the description. Please Don't forget to subscribe, and don't forget to share to your friend. See you when you see me. Thanks for watching.